So I just made this little animation with a robot arm opening a door. I'm currently challenging myself to find like new ways to open the door, so I came up with this one. And it's really powerful rig, so I figured I'm gonna show you how I made it. It's quite easy to control. We just have a few control bones like this one, and then this one is for the tip, and this one can like fine tune the tip. And then of course we have the base, so we can rotate it. And yeah, I mean, this wig can actually do quite a lot. I think it could be really useful for some kind of like factory, like, you know, you can pick up things and then attach them in all kinds of different angles. So let me show you how I made it. So let's go into layout mode because things are a bit easier to see. Let's also get rid of this one. This is just a collection instance, right? I put all of this into a collection, animated it, and then you can go here, add collection instance, and arm door. Really useful for animation, so you only have to animate one thing. But let's get rid of that. Let's also get rid of the door. I'm gonna get into that in the end. And let's focus on the arm first. Right now you can only see the control bones, but of course there are a few more, which is here in the armature. If I shift click, now we can see both layers. So this is the layer where all the bones are. And then I put the control bones in the second layer. That just makes it a lot easier to animate. This arm basically consists of two things. First, we have an inverse kinematic that controls the base arm. Attached to that is this double hinge joint. Let's just go through it step by step. Okay, I just hit a few things so we can just build it up step by step. And on a side note, if you're wondering why my bones are looking like this, because here into the armature tab, usually it's octahedral, but I chose display as B bones, and then I also chose to display the axis. Makes things a lot easier. The nice thing about B bones is you can select it and hit Control Alt S, and then you can scale it like this, and that doesn't affect the scale of the mesh that is attached to it. So you can, you know, change the bones a bit. Makes it a lot easier to keep them apart. So everything is connected to the spaceman. Actually, let's do the Control Alt S and scale it up a bit. This is the base of, like, this is the entire machine. I just placed it on top of this one so I can move it on the y-axis a bit. But yeah, this is the basic. So let's consider this one the base. Parented to this, I have 1 and 2 bones. This one is of course also parented to it, but it's the control bone for the inverse kinematic. So it's parented to my base, but it is not connected to the chain. And then here in the bone constraints, we have the IK constraint. Target is this bone, so it's always going to try to point to wherever that bone is. And chain length is 2, so it affects this one and this one, right? The chain length always includes the bone that the IK is sitting on. And then I'm using some constraints here because I don't want this thing to go like in all weird directions. I only want to rotate it on the X. So we can go into the bone tab here, and when it is part of an inverse kinematic, you can lock some axes. Those axes, of course, always refer to the local axis of the bone, which you can see here. Again, display S, and then here in front you can, no, not in front, sorry. You can just choose to display the axis. And whenever you click on the bone, the one that gets like saturated color, you can see those are the axes of the bone that I just selected. So I only want to rotate on the x-axis for this one, and here's the same, right? I want to pivot around this point on the x-axis. If I didn't do that, let's see here, bones. So where the hell? IK constraint, if I remove that, actually it's looking good. Come on. Okay, but now if I remove that and I start rotating it, you can see it's things are getting pretty funky. And of course I don't want that. This is a machine that can only rotate on those axes, so I will present that in the IK. Yeah, this is pretty much it for the first part. For the second part, I have this double joint. So this bone is parented to this one. And of course, you can start the IK any point in the chain. Sometimes people think you always have to do it in the end of the chain, but no, you can just... the tip of this bone is always going to point to this one. But then, of course, you can still keep that chain going and attach things to it. So this one is parented to that. And this bone is parented to this bone. It is actually separated. If I go into F2, on a side note, I always keep my rest pose in like vertical and horizontal lines. It's just so much easier to model things and then align them. If my rest pose were like all twisted and rotated and then I'm starting to model something new, I always have to figure out the right rotation. This way, it's so easy. And I keep this like outside of the actual animation. I have this one frame where everything is the way I want it, like that. So if I go into edit mode, I can see it like this. Anyhow, this is the bone that I was talking about. And those are the bones we don't need. That either. So this one is parented, but it is not connected. Right, so you can take a bone, like say right now this one is connected, but if I hit Y on my keyboard, now I split it. But then I can still move it and I can like shift select this bone and I hit Control P. And then I say connected, but keep offset. So now it is connected. And this is what I did with this bone. So back in post mode, so it's connected to this one. And now the idea is pretty much, I want one bone to take care of one rotation and the other bone take care of the other rotation. Hope that's not too confusing. Let's go through it. And I was going to post a link in the description of a really nice tutorial where someone explained how to do this double joint rig in detail. I added a little bit constraint here for fine tuning, but the base is pretty much the same. So we have this bone here, once again connected to this one. And then we have a bone constraint here called locked track. Might be a bit confusing at first, but once you understand what those things mean, it's quite easy. So we have a target, something that we want to point towards, and that is this bone. This one is only parented to the base. Just in case I rotate this on the Z-axis, this one rotates with it. Actually, would be kind of cool. I'm realizing now if this weren't always connected, because sometimes you could attach like the tip of it and rotate this part first. That would look kind of cool. Maybe in the next video. I'm actually gonna write that down. Okay, so for now it's parented to this. So if this whole thing rotates, it's also going to rotate the tip. And so the lock track means it's always pointing towards this one, right? So just target, always have to use armature and then the specific bone, this one. The axis, meaning which axis do I actually want to point towards that, one of the axes of the bone. The y-axis is always the axis of the bone that the bone is pointing towards. You can actually see that if you go to armature, where I show the axis. Right now they're always at the start of the bone, but I can also display it at the end, and then you can actually see the y-axis is always sticking out of the bone. So this is actually the axis you don't really need to be displayed because, well, whatever the bone is pointing towards, it's the y-axis. And of course, this always refers to the local axis of the bone. I don't care about the global orientation. That would be really useful here. So local axis of this bone, the y one, I want to point towards this one. But now we have this locked axis, meaning I can only rotate around one axis. I think somehow you can really choose two here. So you have to choose one axis, and I chose the x-axis. So that means this bone is always going to point towards this one, but it can only do that around the x-axis. So as you can see, if I move this bone, say like G and then Shift Z, it's not going to do anything because I'm not changing the height. But as soon as I change on the Z, you can see this bone is pointing down. And so if I move it freely, it basically tracks the height, you could say. Now, because the second bone is parented to this one, it is going to move around on this one too. But it also has log track, and this one is a bit different because now we only want to move around the z-axis. Hope you can see it here, the z-axis, the one that's pointing up. Once again, the one that's like saturated, a bit darker color is the one of these selected bones. So it's this z-axis, it's pointing up. So this one, if I move it like this, and if I move on the z, well, it's going down because it's parented to this one. And the idea behind it is they represent like a bunch of, let's see, let's hide this thing here. So this one's attached to. So this bone is connected to, or rather this mesh is parented to this bone, right? And so I want to rotate around the X. So this is why here it's perfectly aligned. So let's choose the bone here, G, so it can rotate like this. And then attached to that is the second mesh, and this mesh is parented to this bone. So this one, of course, then rotates, whoops. This one then rotates around the z-axis. So this way I have like this double joint that I can rotate around any axis. And if you think, wow, one joint is pretty, or one double joint is pretty cool, why not have two double joints? Okay, so attached to the tip of this, once again, this bone, this mesh is parented to this bone. So we want to continue with this mesh ends, so to speak. So at the tip of this bone, we have this bone connected to it, which is, it's basically exactly the same. We have this, let's see, those three, that's the first double joint, and then we have those three, that's the second double joint. And we just attach it where the first double joint ends. So this one is parented to this, and this one is parented to this, but it's not connected. This one is connected, of course, but whenever I move this bone, controlled by this one, I want to move the tip of the other joint. And yeah, they're pointing to this one. Just one thing to keep in mind, since the axes are switched now, but I want to rotate the first one around the z-axis. So the y-axis doesn't change, we always want the y-axis to point towards something, but now I'm locking the first one on the z-axis. It can only rotate on the z-axis right now. And the second one is now locked on the x. So this is pretty much the same. And then of course the meshes are parented to that. And here just one little trick I did. I added a copy location, and I want to copy the location of the second one. And the nice thing is, with the influence, I can choose how much. So at the N tab, I go to item. This one still has a position right here, the X and all that. And the constraint, if you look at the position here, it doesn't change it at all. So it's always going to get saved. But of course, as soon as I make the influence to 1, means the position of this first pointer is always going to be wherever the second pointer is. But if I choose like something 0.5 or 0.4, now when I move the second pointer, it's kind of doing like a mix of its own position, but also, 40% of wherever this other thing is. And that way I can get like this nice controllable joint, and I can change that one wherever I want. So yeah, I have like full control over this thing. Okay, let's take a look at the hydraulics. As I mentioned before, they don't really control anything. They're really just tagging along, so to speak, which is really nice because you can just animate and you don't have to worry about like the hydraulics, like poor engineers that actually have to move machines by only like this is all I have. I need to push this thing up and down and then figure out where does this thing actually go. But good thing is we have control bonds, we can do that first, and the hydraulics is gonna take care of itself. So it's quite simple. It consists of 4 bones, and here I have only 2 meshes. So I have this bone, and it is parented to this bone. It is not connected, meaning it's free floating, but of course whenever I move this bone, which I can't because it's part of the IK, but if I'm moving this bone with the help of the IK, as you can see, because this one is parented to it, it's just gonna stay there. And then we have a similar thing here. This one is parented to this one. So you just move it somewhere on the axis and then parent it and connect it to this bone is the actual bone of like this pipe. This mesh is parented to this one. And here we have the same for this bone. And one thing to keep in mind, in case you can see, let me rip this apart. That's too much, come on. This bone is flipped, right? So you can see it starts here and it's pointing towards this one. This bone starts here and it's pointing towards this one. And let's go back here a bit. And then they just have a locked track. And I have this bone. This bone points towards this bone. And this bone points towards this bone. And once again, we need to choose one axis that we want to point towards. So once again, we're choosing the Y because that's where the bone already points to. And we lock it on the X. So can you see it somewhere here? We have the X. It's kind of hard to see. Oh yeah, it's like unfortunately under this bone. I also can't see it here, right? Nope. Go to wireframe so you can see the axis. Holy crap. Okay, here's the axis. So the x-axis, so we can like rotate around this kind of arc. And you might be thinking, why can't I just have this bone point towards the end of this bone, and then this bone points towards the end of this bone? The reason is then you're creating like a dependency loop. If you're coding, you're probably familiar with that because they can crash your program. Blender doesn't crash, but it starts acting really funky because what happens is this bone is going to say, okay, I'm going to rotate towards that bone, and then this bone says, cool, I'm going to rotate towards this bone, and then this bone says, well, this bone is not rotated like that anymore, I'm going to rotate again, and then this bone says, well, this bone isn't rotated, I'm going to rotate again, and so on, and then just things start getting really funky. And the main thing is sometimes you can do that and it looks good and you think, yeah, I can work with that. And then you start animating and suddenly those frames, they start jumping around like crazy. So don't do that. Always have something else that they can point to, and ideally it's of course located where the bones end. So you have this hydraulic. On a little side note, to figure out the meshes, like how far do I want to place this mesh and then the pipe that goes inside. What I did here is I tried to find the biggest squash point. Let me have that damn dog in. So I think for me it was somewhere around, no, it was actually the end. Yeah, so I animated this whole thing and then I looked at it and I thought, okay, this is the point where it's like where the hydraulics is squashed the most. And then I make the bones, extend them just to see, okay, like just make sure that this thing isn't like punching through, which is of course what would happen if I were to go like this, and then it doesn't make much sense with the mesh. So I just try to find this point, make sure, okay, I still have a little bit of one way. And the same with like the further stretch, which, yeah, I think that's here. Here I just made sure that the pipe isn't getting out. Let's see if I do it like this. Yeah, of course, then you realize it's just an illusion. It's not really hydraulics. Okay, then I have a few more things. Let's get the door back here. The door is animated quite easily with another constraint, just an object constraint, which I can see, oh, here it is, called child of, which is a really cool constraint, because it's kind of like you're parenting it to something, but you have way more control. Because, you know, when you parent it to something, then every time you change the scale, location, it changes. Here you can say, I want this object to behave as if it were a child, as if I had parented it to something, but I want to have all those fine-tunes. In this case, I wasn't interested in any of that, but in the influence. So first of all, I parented to this mesh. Nope. Come on. The tip. That's what I'm trying to say. I just parented to this, or rather, I make the child of point towards this well-named cube 008, which is the tip of my rig. And then I can animate the influence. Right? When we start, I have it at 0 because I don't want to move it along already. And now I switch it to 1 with the keyframe within 1 frame. And then for the rest of the animation, it just stays at 1. And yeah, so if I were to put it to 0, it would be right here. This is pretty much it for the door. One last thing, this lock is also a cool thing. I found that in a ThinkCG cookie video, something super old. It was Blender 2.7, but turns out it's still a pretty cool trick that you can use in any Blender version. And that is, I animated those things by parenting them to this circle. So they actually parented. I could have used the chart of constraint, but just a different way. And the animation that I have is I'm scaling this circle towards the center. And the reason they don't get smaller when I scale the parent is because they have this limit scale, and I set everything to 1. So I just say I want the scale to be 1, no matter what happens to the parent, aka the circle that is indeed getting scaled. And then I can just scale it. Let's see. Grab here, scale towards individual origins. Right, I can scale it, and I can move those things. Yeah. That is pretty much it for this animation. Yeah, I hope you learned something. If you have any questions, let me know. I'm gonna do a lot more Blender stuff in the near future. I'm kind of addicted to it, like to an unhealthy degree, but you know, it's fun. So I'm gonna keep doing Unity tutorials for sure, because I think the coolest thing about Blender is still that you can make things, take to Unity, then you put on your virtual reality headset and you're like standing inside this scene, and it's just mind-blowing. So definitely gonna continue with this. So I just want to get really good at Blender right now, so I have actually cool things to look at in virtual reality. But yeah, definitely gonna continue Unity, and also gonna do a bunch of tutorials like how you can combine those things. Because unfortunately you don't have all these nice bone constraints in Unity. Been thinking about, yeah, you could recreate them, but that would be a lot of math. But so I'm gonna try to find out some like breeds in between, like how can you make those animations, maybe not just bake them completely, like you can always do that of course, but you have the bone constraints, make your perfect Blender animation, and you just bake every frame, take that to Unity. But of course it would be really cool if you can have this kind of control in the game. Anyhow, thanks a lot for watching. Hope you learned something. Comment, question, whatever, tutorial request, just let me know in the comments. And of course, subscribing, liking this video would really help me out. So thank you and goodbye.